Hi, my name is Devin Grenard. This is AI and Pandemics, Determining Outbreak Potential Across Towns and Cities. So what's the problem? The problem is that we're reactionary and slow. Many aspects of the COVID-19 prevention are reactionary. Lockdowns and mask mandates often only occur after a massive rise in cases. And vaccines are really good, but they take a really long time to produce. So we need something quick, we need something effective, and we need something preventative. So that's where the AI comes in, the AI that determines outbreak potential. Right, so we have tons of data over the past 10 months that's been collected, and we can use that data per town or city to create these daily snapshots of new cases. So these are the factors that have been determined: population density, humidity. Right, these are the factors that we'll be giving to the AI based on the research and data that has occurred over the past 10 months. So you choose a random town or city, let's just say New Brunswick, and you choose a day. I chose April 1st as our starting day, right? And so you plug in all of the answers to your factors for that day, and then the process happens. You use the data to find the outbreak potential. So the AI takes the factors and it weights them randomly. It says population density contributes a lot to spread, right? And this other factor contributes very little, right? And it takes a random guess. It says 37 new cases on April 1st. Well, it's wrong. The real new amount of cases was 9, right? And it'll do that over and over again on April 2nd, April 3rd, April 4th. But then eventually, the AI will weight the factors in such a way that it gets the answer correct, right? So it'll guess 5, and the real new amount of cases is 5, and it'll continue to guess correctly. So that means that we now have weighted factors that can reliably predict how many new cases there will be. So we can use those weights to create an algorithm that now predicts how many new cases there will be in the future, right? So you have new cases, you can calculate total rate of transmission based on that, total amount of cases, and the percent change between the days. So this is just a random example. February 3rd, 2021, right, the algorithm says there's going to be 10 new cases. So what does that mean? Well, that means that we can use this as a predictive tool for the future. You can have these things called breakout days, right? Days with high risk, like the 10 cases on that one day, can be seen as days to take extra precaution. Days with less risk and less cases, more factors that are used to prevent or lessen the spread, can be seen as safer days for groceries or necessary travel, right? But this is the critical part. Because of this, because of how personalized it is to towns or cities, we can provide resources to those areas that need it absolutely preventatively, right? And this is just an example of how the UI might look. So this is really important because now we have a preventative tool that can be used in future pandemics and future epidemics to now predict which days will be really high risk. And the factors might be weighted slightly differently, but this is a really great preventative tool. So here's all the data. Thank you very much.